many schools, engineering isn't taught as a standalone subject. For those schools, it's often left to the science, mathematics and technology teachers to introduce the subject. Here at Kingshurst Academy in Birmingham, maths teacher Eva Cowlishaw and science teacher Amy Lucas are working together to show the students the sort of careers that engineering can offer them.
What we're looking for in the video is what engineers are involved in the project and where is the engineering.
There is a range of engineering disciplines that could be introduced into the classroom, from the obvious ones such as electrical or mechanical, through to the less familiar areas such as bio or chemical engineering. Today we're focusing on structural engineering in a context that many students will have experienced: theme park rides.
For big roller coasters, there's four main types of engineers involved. Structural engineers who design the track, mechanical engineers who deal with the train, the car, the bearings, the wheels and all of those sorts of systems. Electrical engineering, because this ride is powered by an electric motor which drives a chain, which lifts the car and the passengers up to the top of the hill and gives it the energy. And finally, control engineers, specialists who are looking at programming the logic controllers which work out where the train is and give the instructions as to how to launch it and stop it.
Using a roller coaster made it relevant to them. It was interesting and exciting, and there was a point to it, and they'd obviously had experience of those kind of things themselves.
The students will be applying this to their lesson by investigating the mathematics behind rigid structures.
What kind of things are we seeing in those rigid structures? Yes.
It's got strong support on the ground.
Strong support on the ground. Lovely. Okay. What else have we come up with? Anybody over there? Yeah?
Lots of triangles.
Lots of triangles. Good.
Eva challenges the class to create rigid structures using a variety of plastic strips and paper fasteners.
They were looking at creating a structure, which is obviously an engineering process, and they were looking at the maths within that, so looking at the different shapes that they were using and the geometry there, angles, measurements. Okay, Ali, what have you found out?
We found that, like, if you have a square on a building or a roller coaster, it's quite flimsy, so it's just going to fall over. But, like, if you have something like that, then it's rigid and it won't move.
I've put loads of, like, the strips in to make it more stronger, and, like, I've tried to add loads of triangles as well.
Eva moves the task on by highlighting another consideration that engineers need to think about when building rigid structures.
We want to make structures as rigid as possible, but with as little materials as possible, because with engineering, obviously you have to use materials, and the more materials you use, the bigger your costs are. Okay, so we want to minimise the materials, but still make it as rigid as possible.
So to finish the task, the students are predicting which of the three bracing patterns can strengthen a 9-square framework.
Right, the context and the contextual nature of the subject really brings it alive for the students. So it gave them an opportunity to use their maths in a slightly different way and a practical way as well. So it's nice to use materials and get them actually making something rather than just doing it in exercise books. Show me. Liam, do you want to explain what's happened there?
Because there's like nothing in the middle to like hold the middle together, like the two ends just like folding so like the middle just disappears.
Okay, so the end structures are still rigid, but because of that middle bit, yeah, it's disappearing. Okay, that's lovely. Right, the middle one then. Is it rigid?
Yeah.
Sure? Wiggle it for me. Okay, looks pretty steady. Well done, lads. And the last one. So, is it a rigid structure?
No.
No. Okay. So that one's not a rigid structure. Initially, they think that maths is something that they need to do to finish school and to get a job. But I think this one particularly, they could actually see the application and they could see for a different career and for a career that they might be interested in, like building roller coasters, the kind of engineering that they'd have to do and therefore the kind of maths that they would have to do.
Say I wanted to be like making roller coasters when I grew up, then I'd have to learn maths to think of just like measurements.
Loads of kids enjoy roller coasters and they don't think about it as a challenge, but it would be an interesting challenge.
The theme park ride context is also being used by science teacher Amy Lucas. The students are carrying out a scientific inquiry on an ejection seat ride.
The main aim of the experiment today was to look at the types of forces that are in action, keeping them aware of where science happens, the forces that act, and how it all links into everything else they were prepared to do.
The ride is made up of 2-metre rules clamped in place with a capsule fixed on a piece of elastic between them. A light gate is connected so the speed of the capsule can be recorded.
They were modelling a ride they've seen on fairgrounds where you're sprung by a bungee up into the air, get a bit of free fall and then head back towards land. They had to create their model and then test out the best conditions. What would give them the best ride, so what would give them the highest maximum height, what would give them the best time in free fall, how low they had to spring it to actually get it to fly back at a decent rate.
As with all science experiments, for the best results you need to repeat, repeat and repeat.
What did you notice? What sort of patterns did you spot?
As we changed the distance that we pulled the elastic down, the speed gradually got quicker.
Amy moves the experiment on by getting the students to think about what they can change to improve their ejection seat ride model.
The distance of how far the rulers are apart.
Okay, brilliant. So you can make it so your supports are massively over here and see if that affected it. You could have them much closer together. What else could you do?
The length of the elastic that you have.
Could you change the capsule because the weight of it could also pull it down?
Okay, so you could change what your capsule's made of. It's quite important to use science in an engineering context as they need to understand that science is not a standalone subject, that it works with other things and it impacts on lots of different, perhaps career choices, lots of different choices they might go on to make in the future.
Science and maths, I didn't know how they were so closely related, and in the maths lesson we found out about all the structures, and then when we went into the science lesson we had to use the structural, like the thing that we used in maths, to put it into the science lesson so that we could make our bungee ourselves.
For the final task of today, the students will be taking part in a mock interview. This provides an opportunity for Eva and Amy to consolidate the learning and for the students to practice the skills that they would need when applying for a job. Some of the class will play the interviewees, applying for the role of a structural engineer. The rest of the class will play the part of the interviewers. Eva works with the interviewers to formulate questions that they think will help them choose the right candidate, some related to the maths and science that they have been studying.
We could ask about what would be dangerous, because if they know the danger points, then they'll probably know the safety points as well.
Why are you asking them about their hobbies at the beginning?
Because to get them relaxed and so they're easy to talk to.
Why do you think they need to be able to be good at working with other people?
So that they don't have arguments, so that, just to keep it as a good team, so they know what they're doing.
Okay. They got to look at what skills they would need to be able to go into an engineering role and got to think about the things that they'd done already and the different skills that they already have and the things that they've been doing in school.
Amy works with the interviewees, who have to complete an application form and try to predict the questions they may be asked.
I think it's be quite a hard job, so I think that if they had some previous work, then it'd help them.
For my hobbies and interests, I've put building roller coasters. Would that be a good one?
It might be, yeah.
Okay.
Is it true?
Yeah, I love making them all the time.
I think the surprises came from the options that they chose to put down for hobbies and things. So I think they were sort of thinking a bit too rigidly to that I'm going for an engineer's job, I'd like to be this, I will stick my hobbies to be engineering based.
3 candidates, Ali, Amy and Liam, are going head to head in front of the panel.
In the ejection seat ride we did earlier, what forces acted on the capsule?
We used gravity pulling it down, up thrust up, and the force of pull.
What experience have you had in engineering at school or in other jobs?
I've had lots of experience, as in today I made a small scale model of an ejection seat.
After you had seen the ride you made this morning, what improvements do you think you could have made?
We could have tightened the string a bit, so like it could have made it go up a bit higher, bounced it a bit more.
Thank you very much.
As the interviewers head off to make their final decision, how do the candidates think it went?
It went okay. It was a bit shaky. Some of the others were a bit more natural.
It was quite scary because, I mean, in a real interview for a job, it probably would be quite scary as well.
They all seem to have the same hobbies. They all listen to music, watch telly and build models. Amy said that she had lots of experience, but Liam had no jobs but was taking OCT, maths, science. But it's whether we want to have someone with experience or someone new with new ideas.
Probably we need someone that's a bit fresh and a bit like that could maybe bring something new.
For the candidates, it feels like time has stood still. But who do they think will win?
No, just thought Ali was better, naturally.
Ali.
I think maybe Liam, because he had loads of ideas.
So we all decided?
Yeah.
I think the interviewees panicked a little in the final activity. They were very, very brief in their answers. I think if they hadn't perhaps had the whole weight of all of the people watching, they might have explored a bit around their responses.
It's the moment of truth.
We decided that the person we want to have the job of engineer is Liam.
I was really pleased with how the day went. The students responded really well to all of the activities. They really got into it. Their responses, when they were talking to each other, when they were giving answers, was excellent.
I thought an engineer was an engineer. I thought he did it all. But looking at it today, I found there's a lot of roles, and it must take a lot of teamwork as well within the engineers to get it exactly how they want it to look.
I think the more that they see you can use what you know in school in a whole load of different ways, I think that's going to improve what they think about doing in the future.